Alright, what's happening? I hope you all rocked your test, and I'll be sure to have that graded, and we'll go over it tomorrow, but let's start with Chapter 5, Section 5.1, and now all chapter we're going to be focused on quadratics, but today we're going to focus on graphing quadratics. Now again, please make sure you're taking notes. With quadratics, we're focused on parabolas. Alright, and that's functions with an x squared, with an exponent of 2. And you saw some of these in Algebra 1, but as everything, we're taking it a step further. Now, the first thing I want to look at is standard form. Alright, now standard form of a quadratic equation is y equals ax squared plus bx plus c. Now, we're going to look at 3 different forms today, and in each form they're going to give us very, very important pieces of information. And from the forms, we got to be able to pull out that information and apply it to the graph. So in the video tonight, I'm throwing all that information out there. You're going to have it all. And then tomorrow we'll put it more into context with the actual graph. Alright, so one of the major pieces here is our a, our lead coefficient, our coefficient on the x squared term. Now, our a tells us my orientation. And by orientation, the first thing we're going to look at is, does my parabola open up or down? Okay, now remember, a parabola is a U-shaped graph, so it looks something like that. Now, it's going to open up if your a value is a positive. And your graph will open downward in the event your a value is a negative. So again, we're all focused on that a value, whatever that number is. Let's scroll over a little. All right, then the second thing the a value tells you is your shape. All right, now the first thing we want to talk about is I'm going to say the absolute value of a is equal to 1. Okay, if the absolute value of a, and I say absolute value of a is equal to 1 because that means 1 or negative 1. The sign in front tells us simply up or down. And then the number itself tells us the shape. So we're looking at the absolute value because the negative just says up or down. At this point, it's kind of irrelevant because we've already figured that out. So if it's equal to 1, we say our shape is normal. All right, in a parent function graph, your u would be somewhat normal. All right, now in the event your a value, absolute value of a, is bigger than 1. So if it's 2 or negative 2 or negative 4 or 1 million, all right, that causes our graph to be very narrow. All right, narrow. So in a sense, our u would be skinnier. It would rise faster. All right, now if our a value is less than 1, however, greater than 0, so like 1/2, 3/4, 0.67, something like that, that would cause our graph to be wide, and our u would be a wider shape. Alright, so that's what the a value tells you in standard form. That value is extremely, extremely important. Alright, the second form we're going to talk about today is intercept form. Now, simply by the name, you can probably guess what it tells us. Alright, that's intercept form. Now, intercept form is going to be y equals, there's that a value again out in front, and then we're going to say x minus p times x minus q. So intercept form, it's kind of like factored form. Think of applying ZPP, zero product property here. Okay, again, the a value still tells you the same stuff as above. All right, our a value is still going to refer to the orientation and the shape. So all rules above apply. Right, all rules above apply for the a value. But the intercept form also tells me my intercepts. So it's opposite of p. So p comma 0 would be one x-intercept, and q comma 0 would be my other x-intercepts. Now you say, how can it have two x-intercepts? Well, again, think of it. If this is my graph, and my parabola is a U-shaped, it's going to cross that x-axis in 2 places, hence the x squared. All right, so 2 solutions, 2 x-intercepts. All right, and then our last form is our vertex form. Now, guess what the vertex form tells you? All right, the vertex. Now it's y equals a times the quantity x minus h squared plus k. Now, sometimes we refer to vertex form as graphing form. All right, because once we have an equation in vertex form, it's very easy to draw a graph. And that's just not with parabolas. That's almost any graph. All right, now, again, the a value holds true. All right, it tells me orientation and shape, same rules apply as standard form. So all is good there. Now, vertex form tells me one other important piece of information, and that's the vertex. So it's opposite inside, which is h, comma outside, k. So it's referring to this piece would give you your x-coordinate, this piece would give you your y-coordinate. And that's what we call our vertex. Now, the vertex refers to the tip of our graph. So in this case, it's the lowest point, our minimum value on that shape. In the event our graph opened down, it would be the tip there. That would be our maximum value because that's the highest point. Think of it on your roller coaster. You've reached the highest point before you drop. All right, now, so those are my three forms. We have standard, intercept, vertex. They all give us very different pieces of information. Now, the important thing is you have to be able to take intercept form and vertex form and write it into standard form. All right, so that's what we're going to practice here. No matter what equation I give you, you need to be able to convert it to standard form. All right, so let's say I give you this equation in intercept form. Y equals -7 times the quantity x plus 3 times the quantity x minus 2. Now again, I want it in this form. All right, so y equals ax squared plus bx plus c. So I want your x squared term first, your x term in the middle, your constant term last. So looking at this, how are we going to get there? Well, the first thing we need to do is get rid of my parentheses. So I need to FOIL out this multiplication problem here. So I have y equals -7. Now in parentheses still, so in a sense there's like brackets around this, I have x squared minus 2x plus 3x minus 6. Alright, so combine your middle terms. So y equals -7, x squared, I'm adding these two. -2x plus 3x is 1x minus 6. Now I'm not there quite yet. I still need to distribute my 7 to everything in order to be in standard form. So y equals -7x squared minus 7x plus 42. And now I am in standard form. Alright, so no matter what form I give you it in, you have to be able to get it to standard form. And as we go through this chapter and our skills evolve, we'll be able to go backwards too. We'll be able to go from standard form to intercept form. Alright, but now I just want you to be able to write everything in standard form. Alright, let's try another one. Now this time I'm going to give it to you in vertex form, and I want you to convert it to standard form. Alright, so y equals 1/2 times the quantity x minus 3 squared plus 4. Alright, so now I've given this to you in vertex form. You need to be able to recognize that that's vertex form, and we want to go to standard form again. So again, I want to make it look like this. Alright, so we're going to start this time with this piece here. Alright, so I have y equals 1/2. Now, this is the quantity x minus 3 squared. So this is x minus 3 times x minus 3 plus 4. Because the exponent's on the outside, so it's everything inside multiplied by itself. So again, we're going to have to FOIL that out. So I have y equals 1/2. Bam, 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 bam. So I got x squared minus 3x minus 3x plus 9, -3 gives me 9, plus 4. Now again, you have to be very careful. Alright, this whole piece came from there. So you can't add that 9 and 4 yet. Alright, this 1/2 is attached to these parentheses, and we always take care of multiplication first before addition. Alright, remember PEMDAS? The order of operations. So let's combine our middle terms. X squared minus 6x, negative 3, give me negative 6, plus 9, close parentheses, plus 4. Now from here we need to distribute my 1/2. So I have 1/2 x squared minus, well, half of 6 is 3x, plus 9 times 1/2 is 9/2. Now these two are like terms, so we need to combine those. So we have y equals 1/2 x squared minus 3x, 9/2 plus 4, well, is the same as 8 over 2, which is 17/2. So if I had 9/2 and 8/2, I get 17/2. Alright, and there you are in standard form. So our algebra skills are back and in full effect. Tomorrow we're going to take this standard form, we're going to use our calculator, we're going to graph it and find lots and lots of properties and cool stuff about this graph. So until then, I'm out.